Hi, welcome to another video. So I've made some progress with this Epson chip. This is the Epson S1D13517. This is 16 megabytes of memory. This is my PIC32 microcontroller. This programmer is currently powering this board and it can't run this Epson chip plus the memory plus this at full power, so I've slowed this down to 120 megs. I've installed my SD card. I've got 13 16-bit bitmaps. The program, which I'll put on GitHub and put a link in the show more, will initialize this 2 gig FAT16 SD card, find the pictures automatically, load them into 13 buffers, and then display them. As I explained in a previous video, this is 16 megabyte. So if this screen is 800 by 480, that's 768,000 bytes if there are 2 bytes per pixel. However, as previously discussed, this Epson chip converts your 16-bit color into 24-bit color, which are 3 bytes per pixel. So you have to adjust the buffer size for this memory to accommodate this screen size 3 bytes per pixel. 24-bit color, even though 16-bit color is going in. I'll turn the power on and you'll see the bitmaps being loaded. The white screen you see in front of each picture is the blank memory. Remember, I've slowed this down to 120 megs. That's initializing the SD card. That's all the pictures. Small delay so we can see what's happening. That's the first picture. So when each picture is converted to 24-bit, that's over a megabyte in size per picture, so I can only fit 13 pictures. I think this is picture 7. This is slow reading off the SD card. I could make it faster if I connect my battery supply. So they're being loaded into memory as this happens. This is picture 13. Well, now they're all in memory and the Epson chip is simply running through each of the 13 buffers. Back to 1. So unlike videos you've seen in the past, you do not see this screen being refreshed. The picture just appears. Now that's this Synchronous DRAM, this one here. It's running at 90 megs from this Epson controller, and this Epson controller is controlling this memory. If you wanted to know the speed of this Epson controller and how quickly it can draw a WVGA, so wider VGA, 800 by 480, that's the speed. Pretty impressive. I've got a 600 millisecond delay after each picture, just so you can see it. Now let me take out the delay. Now you don't see the white screen because the power hasn't been off long enough, so the pictures are actually still in the memory. Picture 7. Remember, my microcontroller is slowed down to 120 megs. That's 13 pictures. So this Epson S1D controller, when accompanied with this memory, is certainly a fast system. Fast enough for video, except I doubt this microcontroller could keep up. Now I've established how the memory works, how to allocate the size, I'll now experiment with the alpha blending. So the C file I'll release automatically initializes and reads your SD card, formatted to FAT16. It's got a number system, draws numbers, no blanking required. It draws those letters you saw for the SD card boot up sequence. The only libraries I'm using are SPI and one part of the maths library, which is converting a long to a string. There's no library for the TFT, no library for the Epson chip, no library for the memory. It's all raw code in the C file. If you want the C file, have a look in the link below. If you want to make a donation for the time I've spent getting this working, there's also a link in the show more. Hope you enjoyed it. Thanks for watching.